the Cassini mission has made stunning discoveries about the Saturn system. The spacecraft found evidence of water-ice geysers jetting from the surface of the moon Enceladus, which feeds particles into Saturn's outermost ring. On the closest pass yet, Cassini gave us a roller coaster view of the bumpy ridge around mysterious Iapetus, and revealed that Saturn's orange moon Titan has Earth-like features such as lakes, clouds, and mountains. It has hundreds of times more liquid hydrocarbons than all the known oil and natural gas reserves on Earth. Discoveries like that are why NASA extended Cassini's tour another 2 years, and Cassini tour designers worked at breakneck speed to come up with its new travel plans. NASA has added 2 years to the Cassini mission to Saturn. Where to go? What to see? To prepare for this extended journey, engineers had to chart some tricky maneuvers, trying to fulfill the wish list of 200 scientists.
The spacecraft's going. You have a locomotive speeding down the track, but they haven't built the railway yet, and we're up front laying track. It's a lot like if you're in AAA and you go to the you go get a triptych on the counter. Someone sits there with a map and draws out with a highlighter where you're going and plans out the trip with you. So the scientists are on one side of the counter telling us what they want to see, and then we're with the map mapping out a route and saying, well, how's this, how's that?
For the last year and a half, Cassini tour designers have been working at breakneck speed on plans for an extended mission.
It's not what you call a low-stress job by any means.
They essentially lay down on the table what they want as far as science goals and science objectives. We come back, we take that off for a couple months, apply astrodynamics.
The people that want to look at the rings want to be up high and look at the rings. The other people want to be down in the same plane with the rings where they can visit all the other moons. And that's a huge tug of war.
So what the tour designers have to do is to take all of these different inputs from hundreds of scientists who say, we have to observe this, we want to look at that, and put that together into a very compact new tour of 2 years.
It has 7 Enceladus flybys at or below 2,000 kilometers, 2 at 25 kilometers.
This tour has 26 Titan flybys. It has 2 high northern ground tracks.
The last Titan flyby is over here, so this is where it reaches the ring plane, so it kind of moves over a little bit.
We show a variety of different tours that are kind of in different flavors. One makes the rings people a little bit more happier than the moons people.
Okay, goals for this PSG, obviously for us, we think it's select the final tour.
They rated the tours in terms of red, unacceptable, yellow acceptable, and green acceptable.
But it sounds like 6, H9, and 8 should either both be red or both be yellow.
Now all the candidates are out there and they've got to pick one.
6, H9, 3 greens, a lime, and a red.
And in the end, it was shades of green.
We will continue this in the executive session.
The science team leaders made the final decision.
And the tour was called this, kind of hard to pronounce PF6H9, but that's the name of this hybrid tour.
Cassini's travel itinerary includes 60 additional orbits of Saturn, studies of the rings, the magnetosphere, 26 flybys of Titan, and close encounters with other exotic moons.
And it's real gratifying that it was a hybrid tour that took kind of the best of a lot of different tours that we had been designing.
The Cassini mission to Saturn has revolutionized our knowledge of the ringed planet, and the best may be yet to come.
Be able to fly through space in a complex place full of moons and rings and dust and so on, and be able to navigate this space in such a way as to give Cassini a chance to make all the discoveries that the scientists on the mission would like to see happen. I don't think of it as a wish list. I think of it as a list of potential new discoveries that will be in the textbooks forever, and these guys are the ones who will make it happen.
One reason why we explore is to get answers to the questions, where did we come from, and are we alone? Trying to get the answers takes a bit of detective work, but scientists are beginning to get some clues. NASA's Galaxy Evolution Explorer discovered that a well-known star has a gigantic comet-like tail that's seeding future generations of planets and stars. Water is an essential ingredient for life as we know it, and astronomers using NASA's Spitzer Infrared Space Telescope discovered water vapor for the first time on a scorching hot gas planet outside of our solar system. We've known of water beneath Jupiter's moon Europa, and now there's evidence of an underground ocean beneath the crust of Saturn's moon Titan. What keeps scientists exploring the universe? They're looking for life in all the right places.
We're not looking for aliens. We're not even looking for fossils. We'll be looking for bacteria or signs of bacteria. And the reason for that is because for most of the Earth's history, they have been the predominant form of life. The chances are it may be different from life on Earth, and therefore what we have to look for is it doing the same things that life does on Earth?
Water is a necessary component for life as we know it. So when we think about trying to understand life on other planets, one of our strategies is to understand the water.
We're focusing on Mars because Mars, in its early history, may have been a lot warmer and wetter than it is now.
It looks like there used to be flowing liquid water on the surface of Mars, but today there isn't any liquid water that we can find, or if there is any, it's very infrequent. We want to detect organics because organics are the building blocks for life. Organics are molecules that contain carbon, and we know that carbon is a central element that makes up our bodies and makes up life. So both Phoenix and the Mars Science Laboratory will search for organics on Mars. Phoenix is the next Mars lander mission. When we land on Mars, we're going to land in the North Polar region. That's about equivalent to Alaska latitudes on the Earth, or mid-Greenland. And our job is to land and dig down and sample the soils and ice that we'll encounter in that region of Mars.
Mars Science Laboratory will have sophisticated instruments which will be able to look at the mineralogy in much more detail, but also looking at minerals which either were formed by organisms, living organisms, or show signs that living organisms were around when they were formed. But we're not only focusing on Mars. There are other places in the solar system which may have subsurface water. Beyond the solar system, there are people who are looking at the planets which go around distant stars, trying to analyze their atmospheres. There's no silver bullet. We've got to take all the possible approaches, or at least a large number of them, and put all the bits together to see where to look and what to find. Looking for life outside the Earth to find out whether we're alone or not? Hey, what better job could there be?
Now you're up to date with JPL Highlights. All these videos, plus podcasts and more, can be found on jpl.nasa.gov. Interested in high def? Just click on the HD download link. Sign up for our email news and RSS feeds, and you'll be up to date all year round. Thanks for stopping by.